Ever look at a glass of watermelon juice and wonder how it got there? It's not as simple as just tossing a few melons in a blender. It's a journey of incredible scale, mind-bending engineering, and unbelievable speed. This mega factory can process a mountain of watermelons. We're talking hundreds of tons every single day, turning a simple summer fruit into millions of bottles of pure juice. It's a mesmerizing dance between nature and machine, where technology works to bottle the very essence of freshness. We're pulling back the curtain to show you the whole incredible journey. From the second these watermelons roll in, still dusty from the field, to the high-speed bottling line. You'll see advanced washing systems, robotic slicers, colossal presses, and automation that looks like something out of science fiction. You won't want to miss this. Chapter 1. The Arrival. A river of green. The trip from farm to factory starts long before those big trucks arrive. It begins out in sprawling fields where thousands of acres are dedicated to growing the perfect watermelon. And these aren't just any watermelons. They're specific varieties like the classic striped crimson sweet or the deep green seedless sugar baby, chosen for their massive juice content and reliable flavor. Once they hit peak ripeness, a status confirmed by the signature yellow spot on their belly, the harvest kicks off. A fleet of trucks, each hauling tens of thousands of pounds, lines up at the farms. The logistics here are down to the minute. Why the rush? Because the second a watermelon is picked, its natural sugars start breaking down. This whole operation is a race against time to capture that perfect peak sweetness. As the trucks pull into the factory, the sheer scale of the operation hits you. One by one, they back up to enormous hoppers. But nobody's unloading these by hand. A powerful hydraulic lift tilts the entire trailer, sending an avalanche of thousands of watermelons tumbling into a massive channel. It's a river of green, the official start of their industrial transformation. These channels, called flumes, are filled with gently flowing water. Since watermelons float, it's the perfect way to move them in huge numbers without a single bruise. As they bob along, the first quality check begins. Keen-eyed workers stand guard, their eyes scanning for any sign of damage, disease, or underripeness. A crack, a soft spot, or the wrong shape could wreck the final juice. Any melon that doesn't make the cut is quickly netted out of the line. This first step is critical. One bad watermelon could introduce off flavors that would spoil an entire batch, and consistency is everything. Chapter 2. The Great Wash. Purity begins. Here, after their little float trip, the watermelons are ready for a bath. And this isn't a quick rinse. It's a multi-stage deep clean designed to scrub off every last bit of dirt, field debris, and microbes. The final juice is only as good as the fruit going in, and that means it has to be impeccably clean before its skin is ever broken. The melons float into what looks like a cross between a lazy river and an industrial car wash. First, they take a plunge in an immersion tank where powerful water jets create a swirling vortex, knocking dirt loose from the rind. It's as effective as hand washing, but on a massive scale. But water alone isn't enough. To really sanitize the fruit, the water is treated, often with ozone. Ozone is a powerful sanitizer that kills bacteria and neutralizes pesticides. But here's the clever part. It then breaks down into simple oxygen, leaving zero chemical residue behind. Automated sensors constantly check the water's sanitation levels, making tiny adjustments in real time. From the tank, the watermelons travel onto a conveyor and through a tunnel of huge rotating brushes. These soft bristle brushes scrub the entire surface of each melon while high-pressure nozzles spray them with fresh, clean water. It's the combination of mechanical scrubbing and powerful rinsing that gets them squeaky clean. And don't worry about waste. The whole system is often a closed loop. The used water is captured, filtered to remove debris, re-sanitized, and pumped right back into the start of the line. Finally, after a last rinse with pure water and a quick blast of air to dry them off, the gleaming watermelons emerge, shining under the factory lights and ready for the next step. Chapter 3. The Ascent and the Blade. Precision Engineering. Clean and sparkling, the watermelons now head upwards, towards the heart of the processing floor. They're guided onto wide, cleated conveyor belts, basically escalators for fruit. The rubber cleats grip the heavy, round melons, carrying them up a steep incline without letting them roll back. It's a hypnotic, endless parade of green orbs, all marching towards their destiny. At the top, the game changes from brute force to surgical precision. The melons are funneled into single-file lines, which is key for what comes next. In the most advanced factories, this is where machine vision takes over. High-speed cameras scan each watermelon, measuring its exact length and diameter. This data is fed to the cutter's computer brain. Why all the high-tech fuss? To guarantee a perfect cut every single time. The system adjusts the blades in milliseconds based on the size of the melon that's about to be processed, which means maximizing the amount of juicy red flesh they can get from each one. Then, the moment of truth. Each watermelon rolls into place, and a set of razor-sharp, industrial-grade steel blades descends with incredible force. These are often arranged in an asterisk pattern, designed to slice the entire melon into perfect wedges in one swift, powerful motion. That speed is essential not just for keeping the line moving, but also for getting a clean cut that minimizes cell damage and preserves that fresh flavor. With a rapid series of thumps, whole watermelons become perfectly cut wedges, their bright red flesh finally exposed. Chapter 4. The Crusher, from solid to mash. The freshly sliced wedges travel down a conveyor, and the air begins to fill with that unmistakable sweet watermelon aroma. Their next stop is the crusher, a machine designed for one thing: pure mechanical force. The wedges tumble off the conveyor and right into the mouth of an industrial crusher, usually a hammer mill. Inside this machine, a series of heavy hammers rotate at terrifying speeds, pulverizing the watermelon pieces against the chamber walls. It's loud, it's violent, and in a split second, it reduces solid chunks of fruit into a thick, slushy pulp. Some factories might use a large screw press instead, which uses immense pressure to crush the fruit, but the goal is the same: turn solid watermelon into a uniform slurry called mash. This crushing step is all about preparing for extraction. The juice is locked away inside millions of tiny plant cells, and the crusher's job is to break open as many of those cells as possible. A better crush means a higher juice yield. Engineers here are also fighting a constant battle against oxidation. As soon as the watermelon flesh is crushed, it's exposed to oxygen, which can degrade the flavor. To combat this, the whole process is designed to be incredibly fast and enclosed. Some systems even pump an inert gas like nitrogen into the crusher to push the oxygen out. The resulting mash is a vibrant red mix of juice, pulp, seeds, and even finely ground bits of rind. That's right. The white part of the rind is often included because it's packed with nutrients and an amino acid called citrulline. The seeds get crushed right in there too. It's way more efficient to filter them out later. From the bottom of the crusher, powerful pumps designed to move thick slurries take over, sending the mash on its way to the next stage. If you're fascinated by how your food gets made, do us a favor and hit that like button and subscribe. We have a lot more factory tours just like this one coming your way, and your support makes it all possible. Chapter 5. The Pressing Point. Maximum Yield Extraction. The thick watermelon mash is now pumped through a maze of gleaming steel pipes, arriving at the real heart of the operation: the juice extractor. For a fruit like watermelon that's over 90% water, the best tool for the job is a massive, continuous belt press. Here's how it works. The mash is spread evenly onto a wide, porous mesh belt. A second belt comes down from above, sandwiching the pulp between them. This fruit sandwich then travels through a series of rollers that apply more and more pressure. At first, the pressure is light, allowing a ton of free-flowing juice to simply drain through the mesh into collection pans below. But as the belt winds its way through a series of smaller and smaller rollers, the pressure becomes immense. This serpentine path squeezes and shears the pulp, wringing out every last possible drop of juice. The gradual increase in pressure is key. It gently milks the fruit without pulverizing the seeds or rind, which would release bitter flavors. What comes out is two distinct products. On one side, you have a flowing river of pure, raw watermelon juice. It's still cloudy with fine pulp, but it's juice. On the other side, a flattened, surprisingly dry mat of leftover pulp, seeds and rind peels off the belt. This leftover material, called pomace, isn't waste. It's often collected, dried and used in animal feed, or even used to generate energy for the plant itself. The seeds can be separated, dried, roasted, and sold on their own. It's a masterclass in efficiency. The liberated juice is immediately pumped away because its journey is far from over. Chapter 6. The Refinement, Perfecting the Product. The raw juice coming from the press is the good stuff, but it's not what you'd want to drink just yet. It's cloudy and full of suspended solids, tiny bits of pulp and cell fragments. The next stage is all about refinement, clarifying the juice to get that perfect texture. First, it often passes through a coarse shaker screen to catch any larger bits that might have snuck through the press, like small seed fragments. Think of it as a safety net. After that, the juice heads to one of the coolest machines in the whole factory, the industrial decanter centrifuge. This machine separates materials by spinning them at incredible speeds. The juice is pumped into a horizontal rotating bowl spinning at thousands of RPMs. The G-forces press the heavier pulp solids against the outer wall of the bowl. Inside, a screw-shaped conveyor scrapes this layer of compacted pulp off the wall and pushes it out one end. Meanwhile, the lighter, clarified juice forms an inner layer and flows out a separate port on the other end. The best part: the factory can precisely control this process. By adjusting the speed and flow rate, they can decide exactly how much pulp is left. For a pulp-free juice, they run it at top speed. For a juice with a thicker mouthfeel, they dial it back to leave a specific amount of fine pulp behind. Like the pomace from the press, the pulp solids collected here aren't considered waste. They can be added into other products like smoothies or fruit nectars. Every single part of the watermelon finds a use. Now, the juice has the perfect look and feel, but it's not guaranteed to be safe or stable yet. For that, it needs to visit the lab. Chapter 7. The Guardian of Quality. Science in the factory. Before it can be bottled, the juice has to pass through the factory's nerve center, the Quality Control Lab. This is a sterile, brightly lit world of science where technicians scrutinize every aspect of the juice. Samples are pulled from the line constantly for testing. One of the most important tests is for pH. Now, unlike lemons or oranges, watermelon juice is actually a low-acid fruit with a pH typically between 5.2 and 6.0. This low acidity makes it a perfect environment for microorganisms to grow, so controlling it is critical for safety. Technicians use digital meters to get precise readings. If needed, they'll add a tiny amount of a natural acid, like citric acid, to lower the pH. This not only makes the juice safer, but also brightens the flavor, ensuring it tastes the same in every bottle. Another key metric is the Brix level, which is just the scientific measure of sweetness. A technician puts a drop of juice on a device called a refractometer, which measures the sugar concentration by seeing how much light bends as it passes through the liquid. This test confirms the sweetness is on point and tells them about the ripeness of the fruit that went into the batch. Beyond that, trained tasters in a sensory evaluation room check the flavor, aroma, and color, ensuring there are no off flavors from something like oxidation. And most importantly, the lab is the frontline defense against contamination. Samples are cultured in petri dishes to check for any bacteria, yeasts, or molds, confirming the factory's hygiene is working. This combination of hands-on lab work and automated real-time sensors creates a shield of quality around every drop of juice. Chapter 8. The flash of heat, ensuring safety and shelf life. Having aced its lab tests, the juice is pure and delicious, but it's still a raw product that would spoil in a few days. The next step is pasteurization, which makes it shelf-stable. This isn't your grandma's pasteurization. Factories use a sophisticated method called flash pasteurization, or high-temperature short-time (HTST) processing. It's designed to kill any spoilage microbes with the absolute minimum impact on the fresh flavor. The juice is pumped into a heat exchanger, which is basically a stack of thin steel plates. Hot water flows on one side of the plates and the juice flows on the other, allowing for incredibly fast heat transfer. The juice is rapidly heated to about 72 to 74 degrees Celsius, 165 degrees at home, and held there for just 15 to 30 seconds. This quick flash of heat is enough to destroy any harmful bacteria or spoilage organisms. By keeping the time this short, the process avoids giving the juice a cooked flavor, preserving that fresh watermelon taste. Immediately after, the juice enters a cooling section, where chilled water on the other side of the plates brings its temperature rocketing back down to about 40 39 in seconds. This rapid cooling locks in the freshness. If for any reason the juice doesn't hit the target temperature, a fail-safe valve automatically diverts it back to the beginning to be reprocessed. This brief, critical encounter with heat turns a perishable product into a safe, shelf-stable beverage, without sacrificing the taste of summer. Chapter 9. The final descent, high-speed bottling. Pasteurized and perfectly chilled, the juice is finally ready for bottling. This happens in a sterile, high-speed environment using what's called aseptic filling technology. The goal is simple. Put sterile juice into a sterile bottle and seal it with a sterile cap, all inside a sterile bubble. The bottles actually arrive as small plastic test tube shapes called preforms. The first machine, a blow molder, heats them up and uses high-pressure sterile air to inflate them into their final bottle shape in an instant. These newly formed bottles are then rinsed with a fine mist of hydrogen peroxide, a powerful sterilizing agent. Then a blast of hot, sterile air activates the peroxide and causes it to completely evaporate, leaving a perfectly sterile bottle with zero residue. The sterile bottles are then conveyed into the filler, a machine enclosed in a sterile chamber kept under positive air pressure so no contaminants can get in. The bottles enter a large rotating carousel. As each one is positioned under a nozzle, a precise volume of chilled watermelon juice is dispensed. These fillers often use magnetic flow meters to ensure every bottle gets the exact same amount of juice down to the milliliter. The second a bottle is filled, it moves to the capping station within the same sterile machine. A robotic arm places a sterile cap on top, and it's immediately tightened to the perfect torque. The speed here is just staggering. A single rotary filler can process hundreds of bottles every minute, a continuous blur of motion. Filled and capped, the bottles exit the sterile chamber, their journey almost complete. Chapter 10. Dressed for success. Labeling and packaging. The bottles are sealed and safe, but they're still blank slates. First, they pass through an air knife dryer that blasts off any condensation from their outer surface. Then, they march single file into the labeling machine. A massive roll of labels, printed with all the branding and nutritional info, is fed into the machine. As each bottle spins by, the machine applies a bit of glue, cuts a label, and wraps it around the bottle with flawless precision. At the same time, an inkjet or laser coder etches a production code onto each bottle. This code contains the date, time, and production line, which is vital for traceability. If there's ever a quality issue, this code allows the factory to track a single bottle back to its exact batch. Now fully dressed, the bottles are grouped together. A robotic packer with soft grippers picks up a whole group, usually 12 or 24 at a time, and gently places them into a cardboard case. The case is sealed and then travels to the final robotic stage, the palletizer. This industrial giant picks up the cases and stacks them onto a wooden pallet in a perfect interlocking pattern. Once the pallet is full, it's automatically wrapped in plastic film to secure the load. This finished pallet, holding thousands of bottles of juice, is then whisked away to the warehouse. It won't wait long. Soon it'll be loaded onto a refrigerated truck, heading to a supermarket and finally, to a glass near you. And that is the incredible intersection of farming, engineering, and food science. What part of this massive process surprised you the most? Let us know in the comments. And if there's another How It's Made journey you want to see, suggest it. We're always looking for the next mega factory to explore. So there you have it. From a dusty field to a gleaming bottle, the transformation of a watermelon is a testament to modern ingenuity. In just a few hours, a simple fruit is washed, sliced, crushed, pressed, refined, pasteurized, and bottled at a mind-boggling speed. Every step is a carefully choreographed dance between machine and science, all designed to capture the fleeting taste of summer and deliver it safely to millions. The next time you pour a glass of watermelon juice, you'll know the incredible scale, technology, and care that went into getting it from the farm to your glass.